All right, so for this example here, we have to inverse trig function. In this case, we recall that the derivative of the arc sine is 1 over the square root of 1 minus x squared. Okay. So what we're going to eventually try to do is transform this so that it's the square root of 1 minus u squared. That way we can turn it into an arc sine and then work things out. Okay, and I think of that here ahead of time just for the simple fact that I know my square is being subtracted. So we still want to once again use completing the square, right? Because trying to let u be the stuff inside here just isn't going to work, right? I don't have a 6 minus 2 theta up top. Negative 6 minus 2 theta up top to absorb that the way I'd like to. So it's a problem. But if I can rewrite this as something squared minus, or something minus a quantity squared polynomial, then I can eventually transform it into an integral that will result in an arc sine. So that's what we're looking for now, is we want to complete the square. So the first thing I do here to complete the square is I'm going to group my variable terms together. So I come over here and I do that by writing it as 27. And I'm going to factor the negative out because when I'm completing the square, I'm used to completing it on a positive thing. So I'm going to factor the negative out. And that'll be theta squared plus 6 theta. And then we're going to be adding something onto that to complete the square. All right, we're going to be adding something onto that to complete the square. The process is always, right, the process again is always half of that term, because remember the formula here for a square is that x plus d squared is x squared plus 2dx plus d squared. So we always end up taking half of that number. So we take half of 6. Half of 6 is 3, and then we square 3. So that's what we need to add right here to complete the square. Okay, so I'm going to do that. 27 minus theta squared plus 6 theta. I need to add 9, so I add a 9. Yeah, I actually make that stand out a little bit better by making it blue. Now I have to also account for the fact that I added a 9. But I actually didn't add a 9 to my expression. Because of the negative out front, I actually subtracted a 9. So to account for it on the outside of the grouping symbol, I need to add a 9. Right? Because what again I really did here was add a negative 9. So to account for that, I need to add a 9 on the outside. Okay, then we can simplify. Right? Then we can simplify. Right? 9 and 27 is 36. And then this piece can be factored now as theta plus 3 quantity squared. So we've now turned it into something minus a quantity squared. All right, we've completed the square, and that's going to allow us now to actually be able to work with this integral. So now that we've done the completing the square process on this, we can go back and plug that in. So that will give me the integral of d theta over the square root of 36 minus theta plus 3 quantity squared. Okay. Now, the thing I'm looking to transform this into is eventually an arc sine of 1 minus u squared. 1 minus u squared. So I need that 36 to be a 1. So I have to factor that out. of the square root, or out of the quantity there. Eventually I'm going to take it out of the square root too. So doing that gives me d theta over the square root. So we take the 36 out. That gives me 1 minus the quantity theta plus 3 squared all over 2. Okay, and then I can do a couple of things here now. I can take the square root of 36, which would be 6, and then that's in the bottom, so that'll come out front as a 1/6. And now I have d theta over, and that's not over 2, I'm sorry, that should be over 36. I don't know where my mind went there for a second. It should be over 36. And now I can rewrite that stuff inside as the square root of 1 minus theta plus 3 over 6 quantity squared. Okay. Keeping in mind again that I eventually want to have a u squared, right? So that I can do this process. So that now all has to be one whole quantity squared. So that's going to become my u. That's going to become my u when I carry this substitution through. And again, this is something right now we have to do because we don't have an alternative. In a couple of sections, we will have an easier way to handle this thing at this step, where we won't have to go through all this stretching things around to make it fit an integral that we need. But here we have to do that, and we'll have another technique later on. So at this point, I can start my substitution step. All right, I can let u be the theta plus 3 over 6, and then I differentiate with the derivative of that. 3 over 6 is just 1/2, that's derivative 0. Theta over 6 would be 1/6 d theta. 1/6 d theta. So I need a 1/6 to go with the d theta. But as we look at what we have here, I actually have a 1/6 hiding outside already. So instead of creating a new one, I'm just going to absorb that in and put it with the d theta, so that we have everything we need to carry the substitution through over to u. All right, so doing that, this will become the integral of du over the square root of 1 minus u squared. All right, so 1/6 d theta gets absorbed, theta plus 3 over 6, that becomes u. And then this is just going to be arc sine. This is going to be straight arc sine of u plus a constant, and then we can substitute in for u to have the full blown answer. The arc sine of theta plus 3 over 6 plus a constant. And so now we have worked out our integral. And again, the key was recognizing that the original thing is similar to the arc sine, and then it was the work of first completing the square to get it to that, and then it was manipulating this to eventually get it into a format that fit the integral formula that we know for arc sine. And so now we have our result, that the integral of d theta over 27 minus 6 theta minus theta squared inside the square root is actually the arc sine of theta plus 3 over 6.